big organization, they have always shied away because as we know, they also have access and a little control, if not all, over their business upon their data and their management. So blockchain is a peer-to-peer network of independent nodes that share any kind of value without the intervention of any central authority or any party. To the next one. Yeah, the evolution of computing, right? The computer is frame from mainframe, went to the internet. From the internet, we have social media, and from social media, we have the blockchain. Blockchain has been here since 2009, and we're just talking about blockchain in 2022. Well, let's move on. So, the IP packet versus the block. So, everything we do over the internet is being sent by this particular IP packet. IP packet is the smallest unit of data that can be sent over the internet, right? And component, which is the IP header and the payload. IP packet also need a source and the destination IP address to transact information. Whereas a block, a communication on a blockchain is done by the blocks, which are chained together to form a blockchain. As I've said earlier, the combination of a lot of blocks makes a blockchain. Blockchain also has two important components, which are called the block header and the block body. So web application versus decentralized application. So a web application uses a client-server model to store information and serve end users. Okay, right? So while a decentralized application that runs on a peer-to-peer network of computers. So the traditional web application uses CSS, HTML, and JavaScript to render the front end, right? So the web application fetches its data from the database through an API call. API are application programming interface. There are a set of functions that allow application to interact with existing software component, operating system, or maybe so DApp uses the front end just like application. It uses HTML, JavaScript, and CSS to render the front end, right? But instead of calling to the API, it calls to a smart contract. So a smart contract is what connects the DApp, the decentralized blockchain. A smart contract are simply programs that are stored on the blockchain that run when predetermined conditions are met only. In the interwork blockchain ledger, there are different stages at which ledger works, and they include the following. Um, First stage, that is transaction preparation. So this is just telling us what actually happens when it's created on the blockchain. The first thing that is going to happen is the transaction preparation. So at this stage, let's say Obina creates a transaction that includes the public address of the receiver, right? It has to go with the source digital signature and the transaction message. Immediately it does this transaction is going to be made available to all the blockchain. Then the transaction verification comes in. So the blockchain node work in a trustless model whereby every node a real node, like is an authentic node, right? They receive this transaction that open and they verify the digital signature with digital signature, right? After the verification is successful, they authenticate this transaction and the transaction is being packed in a ledger queue, and it is going to wait until the next node is being created. So then the block generation comes in, right? So the queue transaction that actually happen when the transaction verification process finished, right? The queue that transaction are now arranged together and they form a block by one of the nodes on the network. So in a Bitcoin blockchain, Bitcoin are rewarded to a Bitcoin node. Also, they are also known as the miner. So whenever a block is being created, yeah, I don't know of Ethereum, but whenever a block is being created on a blockchain, right, that particular node that created that block is going to be rewarded with a Bitcoin, and that's because they are actually solving some mathematical complex program underneath. So after block generation, block validation comes in. After you've successfully created your block, right? The nodes in the network are being processed for their validation process, whereby the majority of the node have to acquire consensus. So they have to agree with each other. So the four ways to actually achieve consensus, which we are going to be talking in more detail in one of our next classes, right? The ways to achieve consensus during block validation is to use the proof of work, the proof of stack, or the delegated proof of stack. But the one that is being currently used the most right now, proof of work. Proof of work is actually really, really expensive. That is why I think Ethereum wants to start using proof of stack. Proof of stack is actually cheap when doing its block validation. So the last thing after the validation is you have a consensus between the block that's been verified and added to a blockchain. Right? We are going to see this in the next slide. Everything I will explain from the transaction, right? If transaction preparation to the transaction verification to the block generation to the block validation, then a blockchain, a block is being created and added to a blockchain. Okay, let's go to the next slide. So what are blocks? Blocks are lists of transactions recorded into a ledger over a given period of time. The size period length for blocks is different for every blockchain. So to understand block, let's start with the underlying traditional data model, and then we are going to jump into blockchain network to understand how they are chained together, right? So in the next slide, so in this screenshot, let's understand the regular means of information exchange over the internet. In the world of TCP/IP stack, information is being transferred through a client-server model, right? Where the client server store your information and modify data on a centralized server. So the control of database remain with the designated administrator of that particular. Imagine if the security of that administrator is being compromised. That means that your entire database can be altered or deleted or encrypted. So theoretically, right, a server is just like a computer. There's no difference between a server and a computer. But in practice, the purpose of servers is to actually serve end user concurrently as they're asking for information or asking for data. Okay, so now to the blockchain network. So as shown in this the blockchain network consists of a network of several machines called nodes. These are nodes. The node is a node, all chained together to make blockchain, right? So unlike traditional database, they store their entire information. They don't store their entire information with centralized database. They store their information with each other. So every information that this particular node has, this particular any information that every information that this guy has, every other has a particular information, and everybody has an administrative role over the information. So if one node goes down, just remain with these other guys, and that's how blockchain nodes actually work, right? So the moment a node join a block, it's going to download the updated blockchain ledger. Immediately this guy is being created, it's going to come here, download all the information. It does not actually need to download all the information here, because the information that is here and here is with this particular guy. So it's just going to come and download the information here. If another node comes, it's going to download the information. So the information that this guy also had is going to be shared among these other guys. So everybody has the information. So your information cannot go down, or whatever you're putting on the blockchain cannot go down. Right. So let's move to the next slide. So looking at this simplified blocks, multiple transactions are bonded together to form a block, right? Simplest form, right? It is just a data structure. This is a data structure. Every cryptocurrency has its own kind of customized property. For example, in a blockchain, in a Bitcoin blockchain, right? A block is being generated every 10 minutes, and the size of each block is 1 MB, 1 megabyte, sorry. Whereas in an Ethereum blockchain is really, really fast. A block is being created every 12 seconds. Each block is 2 kilobytes compared to the blockchain of byte. And imagine a blockchain is being created every 12 seconds. Just imagine how many blocks there on the blockchain. A series of blocks, right? So the block header helps us identify a specific block in the blockchain. That is, it contains a set of metadata. So the first set of metadata that it contains version of the smart contract or the blockchain. So the version is like a four byte field, right? That is being used to track software or protocols. That is what the version is, to know the version of a blockchain, right? This time, the timestamp is also a 4 byte field, right? But it indicates the creation time of a block in seconds when a block is. So that is what the timestamp does. Hash of the previous block. Okay, as we said, blockchain is a chain of blocks, right? And it is considered chain because of the inclusion of the previous when a new block comes into the blockchain. So as I've said, it's going to download the initial data on the blockchain, and it's also going to share its own information with the other blockchain, right? The previous hash of the blockchain is part of the component that be in the block. We have the nonce. So in most public blockchain, the way they do their consensus is by mining, as I've said. So when a serious hard mathematical computation happens, right? The blockchain is going to be a miner of that block with cryptocurrency. So the hash of that mining, right, called a nonce. Next thing is the hash of the Merkle tree. So a Merkle tree, as the name implies, is just or a Merkle root or a Merkle tree, uh, but in a reverse order, right? The tree comes from power and spread in branches, but its branches actually This one is actually spreading from the down to the top. So the root hash is in the block header, and it can be used by lightweight nodes in order to verify a transaction without the need of a full transaction list. The next thing is block body. The block body is just part of the block that contains a list of transactions that's been happening on the blockchain, right? In Bitcoin world, one block consists of over 500 transactions on the average. Each transaction has to be digitally signed, otherwise it's going to be treated as invalid. So to do that, an hashing function is used to apply to the algorithm over an actual transaction with a private and secret key, private or secret key rather. So this is structure of a block. This is how a block. This is how a block is. This is the header version, which I've said earlier is a 4-byte feed that is used to track the version or the protocol grade of this particular block. The timestamp, which is going to denote when a block is actually created, right? So the nonce has to do with the consensus mechanism that is used in mining, right? Then we have the hash of the previous, because before a new block is going to be created, it has to download of the previous block, right? Because I'm sorry, I didn't say this earlier. When a block is being created, it's actually not storing it as a data, it's actually storing it as an hash. That is how blocks are being created. So is this hash that is going to be sent to other blocks. So all the information in your blockchain or in your transaction is going to be converted to a SHA-256, even though Ethereum does not use a SHA-256. Ethereum uses KESA-256 to encrypt information, and the size of these hashes does not increase no matter how your data or your information that you're putting on remains the same size, right? So to the next slide, going to help in media, whereby it's going to be an anti-privacy. To actually help from my own perspective, right? Blockchain is going to help artists like musicians, right? Because you can actually own your music. You can actually own your music. There's going to be like and there's going to be like for your own music, and nobody can change it, nobody can recreate it, right? So blockchain has also helped us in gaming. Everybody knows about metaverse now. Everybody is buying properties in the metaverse. I'm sure a few people here actually own property in the metaverse. I know of a few people that actually own property in the metaverse are among us, right? So and so much more. So the use case of blockchain is actually much. We can't cover it in just one class. So blockchain benefits. Blockchain bring numerous benefits to its users, and some of the common benefits include, I'm sorry for the mistake here, anonymity. So does not require user to register their identity. That is if they are not a DeFi. But I think decentralized finance do KYC. But um, there are so many blockchain that do not to actually register your identity. Stuff like MetaMask, stuff like Mail, right? So it also creates decentralization. Blockchain technology was designed to function without an oversight of a central authority somewhere. We don't have to be monitored. Transaction still goes on, right? Blockchain is tolerant, right? Blockchain are designed to keep functioning even if one node fails. As long as there is still a node on the blockchain, your data. So no node are mission critical on the blockchain. There's nothing like that. There's no single point of failure. The next thing is immutability. So for immutability, the distributed ledger maintained by the blockchain is actually designed to make modification or delete of transaction to be really, really impossible, right? You cannot make modification to a data on the blockchain. So transparency, everybody is seeing the distributed, the blockchain is open and wide. You can see every single transaction that is being that is being. You can just go to, if you want to confirm that, you can go to etherscan.io, right? Maybe you can actually verify from your own app. Maybe you've done a transaction for a very long time, like let's say 3 4 months or three. You can copy the hash of that transaction, right? And paste it on the blockchain on your etherscan.io. You are going to see good details about that particular transaction. So they are transparent. It is open, right? So the last benefit we're going to be talking about this night is blockchain is trustless. Blockchain is designed so that users can trust the ledger without trusting anyone on the network. I don't even need to know you. I don't need to know that you are running a node somewhere. All I need to do is to just trust the ledger, right? So, right. So, I've put together a couple of reading references that is going to actually help us. Like, this was actually my first, I think, our first webinar on blockchain. I mean, this document I'm actually showing right now. But because of the people that were not around, and because we were able to record it when we first did it, that's why I'm actually repeating it over again, right? So these are reading references. There's another one that's going to actually teach you everything you need to know about blockchain, because definitely we will not be going through over everything. The purpose of this web series is to actually teach us what we need to know coding smart contracts. Because the truth of the matter is, if you don't know how to code a smart contract, you won't be able to know how to find its vulnerabilities. That's just how it works. I'm sure it's nothing you guys cannot handle, right? So this particular one, I actually added this particular one for people that do not have a programming background. This CS50 is going to really help you understand the nitty-gritty of programming. I think they actually use C, right? It says it's very, very interesting. This particular book is really, really nice if you want to know more about Ethereum blockchain. And all this is a game you can play to know how to contract Ethereum. This is a YouTube channel I recommend to, right? I learned how to code smart contract from this YouTube channel and this one too. So the next one, okay, this too, right? If you want to see everything that has happened on the blockchain, you can use this, right? Or use this to search. So Microsoft Azure Blockchain as a Service, Microsoft AWS, GCP blockchain as a service. Now, blockchain is not a new service; it's actually an existing service, right? IBM blockchain as a service too, and so on and so forth. Yes, let's do solid to learn more. So I put a couple of quizzes. We are not going to be answering these quizzes. It's just meant for you on your own private time, right? So going to be answering this. Now we're going to be talking about blockchain security as well. Why blockchain? Why? So now that we know a little bit about blockchain, I think it's time for us to aspect of it, because the goal of this course is not to actually talk about everything that has to do with blockchain, but to familiarize ourselves with the nitty-gritty of blockchain security, everything that has to be known. Maybe not everything, but most things that have to be known, right? So, because blockchain is a distributed ledger technology, because they produce a tamper-proof ledger or transaction does not mean they are immune to cyber attack or fraud. I think some people might have heard about the last um, the last attack that actually happened. That is the one that was carried out on NFTs, right? The attacker was able to steal a couple of million of dollars, right? Sorry, I didn't talk about this. Oh, really sorry. Digital signature security. Okay, blockchain uses digital signature to ensure authenticity and integrity of data. So that means that transaction are signed that's actually making that transaction, and block are signed digitally to um, are digitally signed to by the selected block creator. That is the node that actually is creating this. That's actually signing this transaction to a block on the blockchain, right? So digital signature should not be unforgettable. You need to keep your digital signature very, very safe, right? Digital signature, they verify your transaction and block integrity. It should be impossible, right? If you have like really, let's say you have like 100 ether on your Ethereum wallet. I'm very, very sure you don't want to forget your digital signature, right? So let's go to the hash functions. So a cryptographic hash function is an sorry, is an algorithm that takes an arbitrary amount of data input, a credential, and produces a fixed size output of ciphertext called a hash value or a hash. Okay, hash functions, they are just chain of block that are joined together, right? Hash function is a one way, is not local and collision resistant. So hash function are what is actually chained together. Are what is actually chaining blocks together in a blockchain. That is what hash functions are. Yeah. So yeah, this is where I was. I was talking about why we need to take blockchain security very serious, right? So blockchain, like the letter security technology itself, into cyber attack or fraud, as we know already. So hackers with deep understanding of this technology can manipulate node in blockchain infrastructure, and they have succeeded in various attacks. You guys should read up on the DOA attack. An hacker exploited a smart contract and that smart contract with just a vulnerability, like a bug in the code. They call it a reentrancy attack. You guys can. So another thing to know about chain is only as secure as the infrastructure that's being run on, right? Assuming um, you're using 256 encryption in your blockchain, great and fine. Let's say another in an old encryption, their data won't be as safe as yours, right? So um, it's definitely not going to be as secure as the new cryptographic technology that Ethereum uses. That is the Tesla 256. Let's not forget about governance also. We need to understand how to manage data, right, on a blockchain. That's if you're actually running a private data in the case of organization, right? Blockchain can all uh, be added to compliance, such as let's say PCI, IPA, and the rest of them, right? Let's take PCI for example. We need to know the kind of OS you're running your blockchain on, right? That's the kind of thing that before in compliance is going to be saying the patches of that OS, the node distribution, where your node is in China, the node management, and so on. So people need to actually look at the compliance aspect of blockchain security, not only the audit part, right? The audit of smart contract alone, right? DeFi hacks. So these are the top DeFi hack from 2020 to 2021 alone. So this data does not contain the DeFi hack of 2022, just 2020 to 2021 alone, and $1.2 billion is already stolen just because of a single bug, just a small bug in the smart contract, right? So blockchain elements that need securing. Okay, yeah, blockchain element that need securing. We have the layer one, that is the get is Go Ethereum is just like a language that you can use to run your local blockchain, right? And we have the Bitcoin core too. Those are the layer one. They are the underlying one itself. So the layer two, which is a Lightning network, is an overlay network on top of layer one. Layer two is typically focused on scalability. So we have this, which is what we are going to be putting our focus more on, right, in the course of this web series, right? They are automatically execute program deployed to the blockchain, and it's only to define conditions is being met. So we have our token, we have our NFT, we have our decentralized application, we have a software wallet, right? Your MetaMask, your um, Binance, and the likes of them. We have the hardware wallet. The hardware wallet are physical devices for storing private keys that are being to store to send and receive funds rather. So they are physical devices, right? So we have our mining software. Mining software are on specialized hardware that perform the mining that we're talking about, right? We have our centralized exchange, Coinbase, your Binance, they have to be secure too, right? So another thing is the decentralized exchanges. So DeFi is built with smart contract and your Web3 front end or your Web3 front end. That has to be um, secure too, right? So the people secure, right? If the people running a network, a particular technology is not as educated and is not as secure as the technology itself, your technology is doomed to fail. So we need to secure the people too. So where we're going to be dropping the curtain for this short conversation or short discussion or short webinar, because I'm going to be asking questions obviously. But starting from next week, we are going to be going into introduction into Ethereum development. So you don't really need to have much to carry on with this introduction to Ethereum development. All you need is your PC, obviously, and a browser. That is it. You can download a Brave browser. A Brave browser is actually nice and it's actually built on blockchain too, right? You can use your Brave or Chrome. I use Chrome sometimes too. So that is all you're going to be needing for now. Then when we proceed, maybe when we get to a certain point that I want to like deploy or run this maybe in an Ethereum environment. Don't even in an Ethereum environment. Sorry, the Linux environment actually. Your Windows can also carry out every development that you want to do, and we might be needing virtual studio, right? So I'm going to open the floor for questions. Look, I'm actually still new to this. Mouth is actually paining me. Guys, please, question. Thank you very much. I'll take your questions now. Brave. You can use Brave or your Chrome. Then I think you should install math extension. You go back to this um, research. Is it this? I think it's this one. So if you watch this to a certain point, it's going to tell you everything you need to get to set up, everything you need to download, everything you need to install. But we are not installing any serious thing. Okay, we might need to install Ganache, a local blockchain software, but this is your best bet to set up, right? That is the first 10 minutes of the lecture or of the webinar or of the training rather. So I'll take questions, please. If questions, where you need clarifications, I'm happy to take them. Wow, no questions. Okay.
Hello.
So I
Yeah, hope you can hear me clearly.
yes, I can hear you.
All right. Thank you so much for this. So, I wanted to ask. So let's assume everybody we in this room want to start a private blockchain. I want you to kind of paint a scenario of how
You're
it's going.
breaking.
Okay.
Okay.
I
I can hear
said,
you. I can hear you.
yeah. Let's assume that all of us in this room right now, we want to start a private blockchain. Can you paint a scenario of a step by step scenario of how we're going to go about it? Did
Hello?
you hear me? Hello?
You're kind of breaking.
Okay, yeah, my network is bad.
Can you type the question
Okay.
instead?
Okay, so I think, can you hear me?
Yeah.
Okay, so I think she's saying that if everyone in this meeting right now is want to start a private blockchain, for example, what are the steps?
Okay. So I think the first step in creating a private blockchain is you need to create a folder for your private blockchain that is on the particular device that you want to install that private blockchain on. Then, after creating that folder, you need to create a Genesis block. That is the first block that is going to be that is going to be like the origin block that is going to be like the first block on that particular blockchain. Then you start your private network. So after starting your private, you will now create external accounts, right? After create external accounts, you are going to fund your account with some Ether, right? To be able to, of course, carry out transactions in the blockchain, right? Then other people can now create block that is going to be added into the Genesis block. And the transaction is going to just, as I've said earlier, it share 256 hash that is being added to the Genesis block. So immediately another person is coming into that blockchain, or another node is being added into that blockchain, the previous blockchain is going to download the hash of that node, and they are going to share their hash with that particular blockchain. That way, in a private blockchain, anybody can create a private blockchain. You can just decide that, okay, you want to, as you said, all of us in this room can just decide that we want to. I'm going to bring my PC, right? I'm going to the first folder, that is the data folder. Then I'm going to create my Genesis block on it. Then remember, you have to be running, like, of course, a local blockchain that you are going to be connecting to. Maybe you use your Go Ethereum to create that local blockchain, or something called Ganache. But Ganache is only used for testing environment. I don't think you can, yeah. Or you can use your Go Ethereum or your Bitcoin Core. And that answers your question. Okay, I think she's typing.
Yeah, it does. It does.
Okay.
Even though it became a bit complex, well, we get it. We get it.
Any other question? Okay, in the absence. Okay.
So I think you have answered my question. My question was will have been so does that mean just anybody can wake up one day and then say I want to start a blockchain?
Not everybody cannot just wake up, but because you need resources. There are some DeFi application like storage. Storage is a cloud storage that actually runs on blockchain, right? That you can connect your hardware, your system, right? A blockchain, you can say that okay, storage. I don't want to store anything in your cloud storage, but I want to outsource my computer to you, so you can store my computer and you get paid for it. So anybody can do that on a public blockchain, right? As long as you're creating transaction, your transaction is being added to other transaction that is going to create a block on the blockchain. But you cannot just wake up one day and say you want to start a blockchain. You need to get hardwares, right? That's your physical devices that is going to be doing your mining for you, right? You need your software. So you need a lot of things. One body cannot. I don't know. Maybe the person, if the person is Ronaldo or every other person, like maybe any other footballer, maybe they can do it, but not by themselves, obviously.
Okay, I think that gave back to a couple of questions from me.
Okay,
Uh,
right.
so I'm looking at it like, okay, so what's the bottom line reason why someone starts a blockchain? Um, I mean, what's the how do I put it now? What's the game behind starting a blockchain? One, then two, what's the difference, the advantage that the private blockchain has over a public blockchain and vice versa?
Oh, okay. So, as I've said earlier, a public blockchain, they are large, and distributed everywhere, right? And they use a native token. On a public blockchain, anybody can participate, right? You make on your Binance, right? People that does NFT, the images you mine, right, are be added to a blockchain. And that is why they say that your NFT is immutable. You cannot change it. Nobody can have access to it and all that, right? That is important. But for a private blockchain, it is a closed membership. It's just set up, maybe an organization that just want to start a private blockchain because they want to have some sort of control over it. In a public blockchain, there is no central of authority. But in a private blockchain, there is a center of authority. They have trusted members in a private blockchain. Though all of the two blockchains actually use cryptography, they use every other thing. The only difference is not everybody can participate in a private blockchain. For the reason why anyone wants to start a private blockchain is because I don't want my data to be stolen. I don't want anybody to hack into my server and steal all of my data. I want my data to be entry, right, or editing my data. That way, you are going to be sure that anything you add or you put on the blockchain is the same, going to be the same way it is, as long as the underlying architecture or infrastructure that is running that blockchain is still live, right? I hope that answers your question.
Yes, it does. So that means that I'm asking. That means that integrity speaks more to private blockchains than to public, right?
Yes, and no. When you talk about integrity, the public blockchain is as secured as the private blockchain. The only difference is just the center of authority, and that is it. So in the private,
Okay.
I want to have, yes, I want to have to all my data. I still want to be able to control my data, right? I want to
Okay. Yeah. Thank you.
So, any other question? All right. Any other question, guys? Yeah. I see Mr. Jones wants to ask a question. Is Tron on still on this call? Uh, sorry. Oh, okay. All right. Thank you guys for attending this the starting of this web series. I know it was a bit shaky at some point. I'm going to. So the next session we're going to be having is going to be next week, right? And I want everybody to come with the same mind that everybody has actually come here today to learn, right? Also, we were able to do that tonight. Thank you guys for coming.